Now, so many of you have been asking for a follow-up video on the previous one where we built ChatGPT as an iOS app. So in this video, we're going to be building the same application but using the Chat Completions API, so that way we can leverage GPT-4, get contextual responses, and I'll be showing you how to use system messages to tailor your application to very specific use cases. In my opinion, that part of the API is a game changer. So if you're ready, let's get into it. Alrighty, so let's get straight into it. We're going to open up Xcode and create a new project. So I'm going to call this project ChatGPT app. Alrighty, so now we have a blank project that we're going to use to implement the ChatGPT API and then get basically an iOS version of ChatGPT. I'm going to structure this video a little bit differently to my last one, where in the last one I started off with the user interface and had to assume the existence of a lot of variables and also a lot of the classes and structs that we hadn't created yet. So what I'm going to do in this video is I'm actually going to create those first, start with the networking layer, build the view model, the service, and then get straight into the UI. That way we'll have everything set up and it'll be a lot more smooth than the previous one. So let's go ahead and create a new file, and we're going to call this chat view model. And then I'm going to rename the content view to be chat view, and then grab that over here as well. And we want to use chat view in our app. So I've just renamed it to chat view instead of content view. You can probably just delete it and then create a new file, but let's go ahead and also make sure you change the preview. And now let's start off with our model. So I'm going to create an extension to chat view. I'm going to create a class called view model. And this is going to be of type observable object because we're going to want to observe that in our SwiftUI view. And inside this, we want a published variable of messages, and this is going to be a list of message. And before we go any further, let's create our message struct, and we'll make sure that conforms to decodable. In this, we want an ID of type UUID, and we also want a content string, so that's going to be the contents of the message. And we also want a date, so like a created at date. And that way we can sort our messages in order of the one we received earliest or the most recent one. This was just meant to be a variable declaration. And now it says we have no initializers, so we'll just init this to an empty array. And inside this, we're going to want a function that allows us to send message. So next what we want to do is we want to create an OpenAI service. And this is where we're going to do a lot of our networking calls, and our view model is going to basically call that. So our view is going to have the SwiftUI view with all the messages. It lets us input text in the text field. Then when we send that message, it gets sent to our view model, which then makes the call to the OpenAI service. The reason we do this is to decouple everything and make sure everything has its own role, its own functionality, and that way nothing is tightly coupled. So we're going to create an OpenAI service. And before we start writing any code for the service, we want to import our networking framework. So what I'm going to use is a library called Alamifier. And you would have seen that in the previous video if you've seen that, or maybe even used it in any other applications that you've built. I'm going to use the Swift package, add packages. And I already have Alamifier, so I'm going to just add Alamifier. I like it to be up to the next major version. Now, if you don't have Alamifier as a recent package, you can just head over to Alamifier's GitHub page and basically just scroll down to the usage and find Swift Package Manager or CocoaPods, whatever you prefer. I don't know if anyone still uses that, to be honest, but I'm going to add the package and we've got Alamifier now. In here, I'm going to create a class and I'm going to call it OpenAI Service. Just make sure I spell that correctly. And all we want in here is a function that says send message. So we're going to import Alamifier. And now we're going to head over to OpenAI's documentation so we can find out which endpoint we're going to be hitting and explain how the request and the response is going to look like. So we're going to head over to OpenAI, and if you haven't created an account, you're going to head over to platform.openai.com. And then you'll be able to create an account there. So once you set up your account and sign in, you're going to end up on a page that looks like this. Now, if OpenAI has changed the way this website looks by the time you follow this tutorial or see this video, what you're going to want to do is head over to the top where it says API reference, click on that and go to, on the left-hand side, you'll see chat. And this is where we're going to get our endpoint for our chat API. We can see here it says create chat completion. Our URL is this. So we're going to copy this URL. We're going to paste it in here. So we're just going to make this a private let endpoint URL. And that's going to be equal to this thing over here. Now, when it comes to the request body, there are only two things that are really required, and that's the model and the messages. Now, when it comes to the model, I'm going to show you how to use GPT 3.5 Turbo and also GPT-4, because there's a slight difference in the way that you use that depending on your use case. So what we want to do is we want to create a body for this. So we're going to create here a struct, and it's going to be OpenAI Chat Body, and this is going to be an encodable. And in this, we want a model. It's going to be of type string, and we also want the messages, an array of OpenAI chat message. Now this is different to the messages that we're going to display, and you'll see why in a minute, but we want to create an OpenAI chat message that we're going to use to send through to OpenAI. So let's create that as well. Struct OpenAI chat message. Let's have a look. What does a message look like? It's an array in a chat format. So the messages look like this. It has a role and content. So we have role, and this can be of type sender role, which we haven't created yet, and content of type string. Let's go ahead and create that sender role, and we'll make that an enum sender role. And the different types are going to be system, user, and assistant. Now, if you have a look at the documentation, you'll find out a bit more about this if any of this is confusing. But basically what we want to do is we want to send a body that has the model and a list of the messages. And the reason we have that is because with the chat completions API, you send through the entire list of messages as well as the most recent message. And that lets the chat API have some context and then be able to give you a more contextual response. Now it says this doesn't conform to encodable, and that's because our message is also not encodable. And we also want to make our sender role a string and make it encodable as well. Now, one last thing before we can even get started with this is, of course, we need an API key. So if we head over to OpenAI and you jump into the top right where it says personal and jump into your account, it'll say view API keys. So if you view your API keys, you can create a new one and then copy that API key. Now, I like to store things in constant files. Obviously, for API keys, it'll probably be stored somewhere more securely, but I'm going to create a constants file, and that'll just be a constant Swift file, and it'll be enum constants, and I'll create a static let OpenAI API key, and I'm going to paste my API key. Now, for obvious security reasons, I won't paste it here, but you'll then be able to use that in your application. So now we're going to go back and start building our send message function. So this is going to be an async function, and it's going to return an OpenAI chat response. And I'm just going to create an OpenAI chat response here and make sure that it conforms to decodable. Now inside this function, I'm going to return, so let's say return, and it's going to be try. I'll make it an optional for now, af.request, and I want the method, I want parameters, I want the encoder and the headers. And so my URL is actually going to be the endpoint URL. The HTTP method is going to be a post request. So this one is a post request. Here we're going to put the body in the encoder. I'm going to say .json, and we want the headers as well. So let's go ahead and create the body. Let body is equal to OpenAI chat body. And in this, the model we want is actually going to be GPT 3.5 Turbo, and the messages are going to be the list of messages that we pass in here. So it's going to be like this, list of messages. We're going to send a set of message. Keep in mind, this message is different to the OpenAI chat message. So this is the messages that our UI is going to deal with, and then we're going to convert that to an OpenAI chat message. OpenAI chat messages only contain a role and content, whereas our messages contain an ID, role, content, and a date. Now you think you can use that, but what happens is when you send a request to OpenAI's endpoints and it has an extra parameter, OpenAI actually sends back an error. So for that reason, we have to create two separate ones, one that our UI deals with and one that we use for our network requests. So what we need to do is before we send this, we need to map our messages into an OpenAI chat message that we can send through with our body. So we're going to say let OpenAI messages equal, I didn't even spell that right, messages equal to messages.map, and inside this I'm just going to return a OpenAI chat message, and in this I'm going to put this dot role and this dot content. Now I noticed that I haven't actually added the role to our message, so I'm going to go over to message and make sure that I add a role, and this is going to be sender role, same as the one we have in the other message type, and then we can pass in these messages, and so we can add this into the body. And now the last thing that we need to create is our HTTP headers. So we're just going to call it headers, and it's going to be of type HTTP headers. And this is going to be equal to a map, and we want authorization. And the authorization for this one is going to be, we're using a bearer token, so bearer. And this is where we add in our API key. So constant.OpenAI API key. And we're going to pop in the headers over here. I didn't even spell it right. Headers. There we go. And the last thing that we want to do is decode the response. So serialize decodable. And we want that to be of type OpenAI chat response.self. And finally, we want to grab the value. So pretty much here we're returning the value. It's going to throw an error because it's optional. Am I correct? Yep. So let's just say we return an optional value, and that should silence the error. Oh, my bad. We need to add await. So because this is an async function, we need to say return try await. And we're pretty much good to go. The only thing left now is to add the response. If we go back to the API reference and go to chat, the response is going to look something like this. So we have a whole bunch of stuff that we don't really need. Let's just go with choices. So this is going to say let choices, and this is an array of OpenAI chat choice, which I'm also going to create. Struct, make sure that's decodable as well. And this contains a message. So this contains an array of messages. So basically choices. So a single choice just contains one message. So choice, let message, and this is going to be of type OpenAI chat message. So it's exactly the same. It has a role and content, and we can pretty much use this. That doesn't conform to decodable, and that's because this needs to conform to decodable. Since we have encodable and decodable, we can just conform to codable as a whole. And same with this one, that can be codable too. And are we good to go? Sweet. No red flags, so it looks like we're going well so far. So now what we want to do is head back over to our chat view model and be able to send our messages. So let's go to our chat view actually. Let's build this. Now we can start with our chat view. We're going to build the chat UI. So with this, I'm going to have a VStack. In that VStack, I'm going to have on top a scroll view with a list of messages, and down the bottom, it'll have a text field and a button to be able to type and send our messages. So let's start off with a VStack, which SwiftUI has already given us. And inside this, I'm going to add a scroll view, and then I'm going to add an HStack. Inside that, we have a text field. The text field will just have a title key and text, and that'll say enter a message. And this is going to be bound to a text variable. So in our view model, let's create a published var current input. And this is going to be of type string. And at the moment, it'll start off with an empty string. And so in our chat view, we want to bring in our view model now. So this is going to be observed object and view model. And let's just initialize that now. It's better to initialize it somewhere else and then pass it in, but let's just initialize it here for now. And in this, we're going to bind to view model dot current input. So now whenever we type anything into our input here, this is saving into our current input that we can then use to send a message. So in this, we then also want a button to be able to send the message. And this button is going to say view model dot send message. And the label is going to say send. And so we have the send here. And then in our scroll view, now we can add the list to be able to view our messages. So this is going to have a for each, and we're going to iterate through viewModel.messages and message. And then we're going to make sure that we identify this with an ID of ID. So \.id. And now for each one of these, we want a message view. So let's go ahead and create a message view. Message view. And we want to take in the role or the message, sorry. And this is going to be of type message. And this is going to return some view. And now we're going to return. Now I think the easiest way to build a message is to create an HStack. And depending on who's sending the message, you place a spacer on either the left or the right. So if message.sender, or we said role, is equal to user, we're going to put the spacer on one side. So it should be, yes, spacer on the left. So if the message role is user, we're going to put the space on the left-hand side so our messages show up on the right. And the other way around will be if the message is from the assistant, because we're not going to be showing the system messages. And I'll explain that once we get to sending those messages. So assistant we're going to put the spacer on the right hand side, and in between that we're going to have text, which contains our message dot content, and then we can obviously style this, but for now let's just make sure we have those messages coming through. And now that I mentioned not having the system message, let's go ahead and add a filter to this. You could probably add this in your view model, but let's just say filter that dot role is not equal to system. So we don't want any of the system messages coming through, only assistant and user. Now inside this, we're going to return a message view and pass in the message. So message that's going through, and that should give us back a message view. So now what we want to do is add the functionality to be able to send that message. So we've already connected our button up. So we're going to go into our view model, and in the send message here, the first thing we want to do is create a new message, and that's going to be equal to a message, and it will have a unique ID, and the role is going to be from sender, so user, and the content will be our current input. The date is going to be now. And then once we've created our message, we can go ahead and say messages.append and add our new message. And now we can clear our current message. Current input is equal to empty string. And it'll make sure that the text field is now empty again. Now to send our message, we're going to have to declare a private instance of our OpenAI service. So private let OpenAI service equal OpenAI service. So now that we've cleared our current input, we want to be able to actually send the message through to the endpoint so we can get a response back. So we're going to create a task so we can run our asynchronous function and be able to say let response equal to OpenAI service dot send message, and I'm going to pass through our messages. And once we get a response, we need to make sure we put an await here, and then we're going to get the response and say let receive OpenAI message equals to response dot choices dot first dot message. And in this case, we're going to now create the message, so the received message, and that's going to be the message type, and pass in, so we create a new UID. The sender is going to be received OpenAI message dot role, and the same thing here, received OpenAI message dot content, and the created at is going to just be the current date. And what we want to do is guardlet this so that we can get rid of any of the optionals. Return, so just so we know if we've got any issues, we're going to say print had no received message. And so with our received message that we get now, we can get rid of the optionals because that content is no longer optional. And we can now append our message. So messages.append, and we can append our received message. Now, because this is running on a background thread and we want to add this to the main thread, we can then say await main actor.run, and I just want cleaner syntax, so you can just put curly braces, and within those curly braces you can append, so messages.append received message. And what that'll do is it'll run the network core on the background thread, and then it'll append the messages on the main thread. And I think this is pretty much everything we need to get the app running, so I'm just going to build and run and see how we go. So if I build and run, I have the app. If we jump in and enter a message, I can say hello and send the message and wait for it. 3, 2, 1. There we go. And we got a message from OpenAI's endpoint. Now here's where this video differs from the previous one in terms of the responses. This one is actually contextual. So if I start off a conversation like this and I just say I want to talk about the weather and hit send, it says, sure, what would you like to discuss about the weather? And if I just say how hot it is, you'll notice that the response, hopefully, is still relevant to the weather. Now, obviously this looks terrible and you probably want to style it a little better. So I guess I couldn't help but do it in this video. So let's go ahead and do this. Content, and let's say background. So we're going to add some padding, and we're going to add background. If the message dot role is equal to user, we're going to return color dot blue, and otherwise we're going to return gray dot opacity 0.2. So if you build and run that, now let's give it a go. It's a little easier to see what's going on. how are you? And we should still get a message that comes back now. Now, if you notice any delays in your responses, there's a good chance it's either your network or the API that's coming back. It's probably taking quite a bit of time. Now, there is a parameter you can send in the body, and that's called stream. And what that does is it actually sends you back pieces of information as the API responds and generates your completion. And that's similar to the way ChatGPT works, and I'll probably cover that in a future video. So if you do want that, let me know in the comment section below, and I'll cover using stream so that you can get pieces of information and not have to wait the entire duration for you to get back a response. A few tips: probably work on the styling. This is obviously terrible styling. And also a good tip for this is if you're not using stream, make sure you have something like a typing indicator, so it says that the system is typing or the assistant is typing back, and that helps with the user experience and prevents your users from thinking maybe the app just stopped working. At least you have something moving and you kind of know that there is a message being generated, but it's just taking a bit of time. Now, the last thing I want to cover is the difference between GPT 3.5 and GPT 4, because when you're using GPT 3.5, you can't exactly use a system message, or you can, but it's basically redundant and doesn't do much. And I'll talk about how you can pretty much simulate a system message with that. Now, here's the great thing about the chat APIs. So what you can do with a system message is actually enhance the way your prompts are received. So if you want your API to focus mainly on educational responses or cooking responses, if you're building a cooking app or a travel app, things like that, you can basically give the system this information beforehand, and that'll tailor the responses that you get back. This is basically your own way of customizing the chatbot to suit your needs or suit your desired output. Now, with GPT-4, what you do is send that as a system message. With GPT 3.5, you just send that as an ordinary user message. Now, of course, if you are doing that, what you will want to do is exclude your first response because it's still a user message. And what I've done is filter out system messages. However, with GPT-4, you can just send that as a system message. So what you can do is actually go into your chat view model, and instead of initializing with an empty set of messages, what you can do is initialize with a message here and send this through, and it's going to have a UID. It'll be sent as a system message, and the content will be something like this. You are a coding assistant. You will help me understand how to write only JavaScript code. You do not have enough information about other languages to give advice, so avoid doing so at all times. And instead of JavaScript, what am I thinking? We're talking about Swift. And this message was sent on this date. And to make sure that this works, because it's a system message, I'm going to change this to GPT-4. If you don't have GPT-4 access, you can request waitlist access by jumping on the website. You'll see something that says join the waitlist. So if I send this, now watch what happens here. Help me with coding. Send the message. Ready for it? I'm here to help you with Swift coding. Please let me know what you'd like assistance with. I want help with JavaScript. Wait for it again. As a coding assistant focused solely on Swift, I cannot help with JavaScript. And that's the perks of using a system message. Now, like I said, if you don't have access to that, you can change back to GPT 3.5 Turbo, but make sure what you do is in your messages, make sure that the message is a user message and not a system message, because it'll completely ignore the system message if you're using GPT 3.5 Turbo. That pretty much covers everything for this video, and I think honestly I'm excited for what we can build with this technology. So I hope this was super beneficial for you and you're able to take this and build some cool things with it. I am working on another video where I'm building a complete app. I'll be splitting that up into a bunch of videos where I'll go into authentication, saving your chat responses, and using OpenAI's GPT-4 to build some cool stuff. So I'll be posting that in the coming days. But if you have any other ideas, feel free to send those through and I'll be happy to make those videos for you. Don't forget to like, subscribe, and of course, leave a comment down below if there's anything that you need help with and if I can help you with anything you got stuck on in this video. And as always, I will catch you in the next video. Peace.